Hey there guys, and welcome back. So we are on the desktop right now just to start off with, but we've got a number of things to look at. So let us first start reviewing. So what I meant to say is, so we'll be all over the place. Let's start out by reviewing where exactly we were last we did this whole entire Desk Gantry thing. So we'll hop over to Fusion, and here we are. And I had the inspect tool up, but this is what we had. Again, I was not at all impressed by this design. It seemed way too boring to begin with, and that was the first problem I had with it. The other thing is, again, extrusion is relatively expensive. Now, that relatively expensive part we will get to in a minute, because right before stream, I started compiling a list of alternative materials because I was convinced that I was going to go with alternative materials. And as it turns out, it's not necessarily very expensive. I have said that in the past. I've said before, actually, I can't remember which one it was, which project we were doing, but I said, you know what, it's kind of a little expensive to do extrusion, but at the same time, it's honestly not that expensive. It's not prohibitively expensive. And one of these things, yeah, alright, compared to some other alternatives, extrusion is not prohibitively expensive, so I will grant that. It is actually a somewhat reasonable. However, there are things I do not there are things with this extrusion that would cause us problems and limit our flexibility in the future, which is why we are talking about what is going on here and basically talking about all the things I thought about while I was on break concerning the Desk Gantry, because again, the Desk Gantry is something I really do want to get up and running, just because that improves my ability A, to use the camera, and B, not to be staring at monitors through my microphone stand, which is my current setup. I'll talk about that more later, but let us, now that we have a good refresher on where we were at with this, hop on over to, we'll hop back over to the camera because I have a notepad here. So, let's talk about an alternative to the gantry as is. So our gantry right now, right, is going to consist of an X gantry, which is, if I draw this in 3D, actually, I should not draw this one. If I draw it in 3D, ignore that front one, goes like this. So these ones are permanent. And then we'd have gantries, Y gantries. I mean, they really, actually, I think in my Excel sheet I labeled this the other way around, which kind of makes more sense in my brain. Let me take a quick look. Okay, yeah. I labeled these as Ys, so we're going to say this is Y. That is a Y. Going this way. And this is X going this way. All right, there we go. So we have our terms. And one of those things, again, one of these days I will get the exposure just right on this camera so you can actually see what I'm writing. Let me pop that out really quick. And actually, that is the other reason why this is important, because it's only half the camera problems occur because, there we go. Again, it's going to be a little bit dark so that you can see my writing, but whatever. I know it looks like I live in a cave now. Half of my problems occur because of the angle of the lights hitting this with the angle of the camera, right? So the lights are right here, pointing down like this, and the camera is right here, which means that that bounces and comes more or less towards the camera. And it's also bouncing, well, I mean, it's lighted, diffuses, and bounces all over the place, but I'm sure the glare would be taken care of partially by moving where that moving where the camera's at, rather. But regardless, this is what we're talking about here, right? So we have three parts here, just for the record. We have these cross beams, which are the Y cross beams. We have the verticals, which just support everything, and then we have the mobile X gantries. And again, there will be multiple of these gantries. In theory, right now I'm looking at 3 of them. One for the camera, one for this camera, I should say, one for the microphone, And then I would like to, as I keep on saying, invest in a better camera. So that would be the third one. So I'd have this camera right here, which I could do, you know, maybe closer up stuff, and that would be better for it. And then I'd have another camera that would be better at taking far away pictures, because when this is mounted on top of the monitor, which is my other setup for it, is to move this to the top of the monitor, the resolution is not great, and it's not good enough to really see the desktop well. So those would be my 3 gantries to begin with, and then if I've decided I had one more thing, I could add one more thing. So again, I know we looked at it in the Fusion, but just a re-examination of that. The next idea for specifically my microphone I want to throw out there, and this is something that I could do, but right now I mean, I could even do it with this. I could, you know, get a gantry system up just for the cameras and still do this with the microphone, but I've got monitors on a stand, okay? And normally I keep these straight together. I have them butted up against each other, but their arms in the back allow them to spread apart, i.e. like this. And I could build an arm that sticks out, and if we view this at a more isometric, attempt to draw this isometrically standpoint, and there is the stand back there. I could have an arm that sticks out like this, right, with the microphone on it, either up and down like this, or one of those things at any sort of angle. My microphone, I don't think is supposed to be facing straight towards me, but that doesn't mean I can't tilt it towards me at all. So that is an option. So I could have an arm coming straight out between the 2 monitors and put the microphone on that. That would, for the most part, I mean, almost completely, I imagine, remove this whole entire problem where I am literally right now staring at the monitor through the camera arm. I mean, not the camera arm, the microphone arm. And on the right hand side over here, I am looking through the pop shield and the microphone itself to look at this monitor over here. So this again would probably get rid of that problem, and that is an option, and it may still happen. I'm putting out there because that is something I have considered. And again, most of this talk is just theory crafting and looking at numbers. So we are theory crafting. The next thing I could do, the arm, the biggest problem with the arm is that it comes from my desk, okay, down over here. So it comes, let me draw. Here is my desk. There's my desk. And the arm is right here on a mount and goes up like this. And then there is my microphone. So that is how my microphone is currently set up. In theory, honestly, all this material, well, there's a couple things there. Let me back up. So possibly what I could do is instead, and I'll draw it on this side of the desk, that way I'm just not taking up more paperwork. If we raise this arm up and mounted this arm up here, I could do something like this, right? And have the 2-point arm, the 2-axis arm. It's not even 2 axes, but you know, the double jointed arm coming down like this, and that would be similar to this, right? That way it's coming down in between my camera, my monitors, and it's not as much in my way. So my monitors are back here right now, right? Well, if it goes over top my monitor and then drops down, it's kind of dodging my monitors a bit, and I can always move my monitors apart again a little bit just so that this part here is clear. And as you can see here, this is my big problem right now, is that it's coming straight across and the microphone is right there. So yeah, it's a possibility. If we did this, the other option, since we're already building this up, we can build it something like this, something like this frame here, okay? And we could, let me just draw that out again. And for this operation, I think I would want a cross beam in the back, so I'd want this to be solid. So I'd want all this to be solid so that it actually holds up. But we could do, in theory, multiple arms like this for the camera, the microphone, etc. Just put them around and then adjust them on the multi-point arms to where we want them. That is a possibility. It's not terrible. It runs into the one big problem I have right now, which is the problem we have with this, and that is that when things overlap. So when these arms, so for example, if this arm, if this camera arm needs to go this way and it runs into this arm right here, let's say is the microphone arm, in that case, you know, we got a little bit of an issue, right? However, we have that same exact issue with this over here. These gantries, as are, can't overlap each other. They can't pass each other because they're all on the same rail. Which moves us on to idea number 1 for overcoming that. And that is, if we are not using the extrusion, we can't do this with the extrusion because when you use the V-rollers on the extrusion, they're clamping in on the extrusion and you can't really get them off, right? But let's say that we use a tube or something of the like. So in theory, if I have a tube and the gantry here is riding on top of the tube, so not clamping the tube, but riding on top of the tube at 2 points in this orientation, okay? So from the front, whether it's a round or a square tube, if we have wheels going like this, okay, and it's just riding loosely on there, well, it's only ever pulling down, and we're not moving it at high speeds, so there's no real chance for it to flip off of the tube, which is one reason why on most builds with extrusion, you have both of these, because you're expecting this to jerk around a bit, and you want this to stop canting. Well, we don't really have that problem. We're not worried about this canting because we're not moving around often and not that quickly when we do. So if they just have the 2 points up here to make contact to roll on the surface, then we're actually doing pretty good. And what I was getting to here is if we build the gantry such that, not the gantry, but the rollers, okay? So here's my roller. If we build a little bit of a ramp on here, we could, in theory, have these rollers be shaped like this. Actually, I want to do the front view. So, how do I draw this? So here is my roller here, and here's my roller here. And then I would have another roller here, basically is what I'm thinking. And when it goes up the ramp, and it's kind of in this orientation, okay? And when it goes up the ramp, it stops when it goes over another one of these. So we have 2 of these about to collide, okay? When this one goes over top that one, and we could even have a wheel right there if we wanted to, wheel front and back, it all of a sudden goes from being on these rollers here, which are hugging the tube, whichever tube it may be, right, onto this center row of rollers instead, and it rides up and over. So that was an idea, and I like that idea just because it's interesting and creative. Problem is that the X gantry here, right, it's going all the way across like this, and our camera or microphone is hanging down like this, right? That's a camera. That's a bit of a problem, right? Because if this goes over top that, then this, let's say this is, there's that, and you can't really see this one because it's inside of it, but here's the other x-axis at this point. You can see how that z-axis is about to slam into the other x-axis, so that doesn't really work. unfortunately. So it was an interesting idea I came up with, but does not actually work. And I did get inspiration for that from some old video I recall seeing on the internet of an railroad idea concept thing. Or maybe it was a trolley, I don't quite remember. But that's, I believe, what inspired me on that one. Popped in my head. The next idea I had was, it'd be interesting if, and I can't think of a good way to make this work, but this is a top-down view now, and here are 2 gantries, and here is 2 z-axes, okay? It'd be interesting if, when these collide, they could actually, there would be a mechanism to actually swap them, so it releases off this side and connects on this side, and vice versa over here. Now, that does not seem terribly reasonable, I don't think. There is, I mean, I think you can make it work. I definitely think you could make it work via some creative design choices, but I don't know that's so reasonable. And the other problem with this, which is why I'm definitely not doing it, is if this fails, my expensive camera that I plan on buying here, that is now going to drop and hit the desk. That is not good. So, you know, it's yeah. That's not great. But it was an interesting idea I had, which is, again, the whole entire point of this stream is just to talk about ideas and, you know, see what we end up with. So, that's not really going to work. Let's see, what else did I have? So I was briefly thinking along these lines with the arms. Rather than having them stuck in 3 points, I was thinking about making this a whole entire circuit. Well, I'll redraw because I don't want to mess up that image. But instead, making it a whole entire circuit. There. I can draw cubes. And each of these arms would travel around the circuit. Now, the reason why that's probably not a good idea is just because in order to get around and past the other axis, which is what this does, this allows you to actually get past other axes, or get to where other axes were at any rate, we'd have to take this guy, let's say this is my microphone, and move him actually away from my face in order to get the camera over here. And then this actually has to come all the way back around, which means that then my other camera, which let's say is right here, then has to follow around, and you can see how that becomes a mess. So even if this is on an articulated arm, you know, yeah, so this can move here, that can move there, and then we can articulate the arm back towards my face. It's a possibility, but it just seems a little bit silly. It doesn't seem to have, it seems like we're adding extra complexity when we just have the same thing here. The only thing that this solves off of this problem is the crisscrossing arms, because you can just move them so that their arms don't crisscross. So that is the benefit that this design has over that one. But again, the added complexity, I do not know actually justifies it, especially when I was not too keen on this idea to begin with. Now, granted, I may be an idiot and this may be the best idea, but, you know, okay. I may be an idiot, honestly. I may just be an idiot. I will say the one thing holding me back on this thing most of all is, and I've said this before, it may just be my imagination, but it seems like I start out stream with the camera, the microphone in the correct place in front of my face, and I swear at some point during the stream it seems to be lower and I have to adjust. That may just be me. It may just be how I'm sitting. You know, I may sit up more later on in the stream instead of slouching down, which does not make psychological sense. Like, normally people slouch the longer they sit. But I don't know what to tell you. All I know is that, I mean, the other thing is that I could be, you know, so used to looking at the monitors that I do sit up in order to see over the microphone. Maybe that explains it, and I am sitting up after I start working because I am now working on the monitors instead of just opening the stream. Okay, so that is a way we can explain that one. But I am just a little skeptical about these articulating arms that they hold position, which again may be totally unjustified. It may be totally unjustified, and I may be an idiot, but that's where we're at right now. So let's go ahead and talk about this thing right here. So the thing holding my devices, whether it's the camera or the microphone, whatever. I'm thinking the easiest way to do this, to adjust up and down, is to have a slotted Z and then have a little clip button that latches in, so press down and release to go up, and otherwise have it you know, be shaped, have the clip shaped such that it wants to release going down. I guess that's the opposite. That's actually release. No, that is release going down. So you can pull it down and it will go click, 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 you know, to go down, but you got to push in the bottom. Here's a little pivot point. You push in the bottom to get it to go up on the slots. I think that's probably the easiest way to handle that, as opposed to, you know, using a thumb screw to tighten it down. That's more prone to failure, more prone to slipping. And it's one of these things where these things really should go up on the axis, which is the only downfall to any of this, because that means I actually have to reach up to the x-axis in order to adjust it up and down. I prefer to grab near the camera, so towards the bottom near the camera, and move the camera up and down. The only reason I'm saying that's not a great idea is just because then these are always extended down. So if I'm sitting at my desk right here and these things are hanging down like this and the camera is like this, right? And here's my microphone and the microphone's right here. You can see how that's a bit obnoxious, right? Whereas if it is the other way, if it now goes up like that and the camera, we'll draw a different kind of camera here. That does not look like a different kind of camera. That's okay. Didn't need to be. But if the camera is up like this and the rest of the z-axis is above, then obviously that's way more clearance and better, preferable. That being said, there's a world in which we only do this on the microphone because the cameras need to move around. So again, the cameras are easier to move around if this stays put and we just slide the camera up and down using that thumb button. Whereas the microphone, again, that being directly in front of my face, and I want to clear up as much space as possible for me to see the monitors. In that case, it probably would be better for this to constantly be down and for me to adjust the whole entire thing up and down with the microphone at the bottom. So in other words, this guy is how the microphone would be set up. These guys would be how the cameras are set up. So that is my thoughts so far. So let us, was there something else here? So I guess the only other thing here is, aside from mechanical swapping, I was also thinking, I wonder if there's some way we can do with magnets. But again, the biggest problem with this setup where the device is actually, well, there are two problems actually, and I didn't actually say the other one, is you can see how these are facing in the same direction right now. Keep in mind that I have 3 right now and may add more. So what happens when this guy needs to swap with this guy? That guy is on the wrong side. So that is actually the other problem with this. But the biggest problem, and the reason it will never happen, is because regardless of how we're swapping, again, the biggest concern is that the swap fails and I end up with a broken camera on my desk. So that is that. Yeah, so I believe I am now going to go ahead and bring you over to Excel, where I really quick threw together some numbers. Excel, that is the wrong window source. Sorry, just a moment. Where is Excel at on this list? It is still using the Excel that had the my D&D notes on it. Oh, there it is, book 1. Cannot read. All right, so here we go. DOS Depot, you can imagine what that is. I, really quick for the heck of it, Googled, and evidently this should be Die Depot, I assume, from in German, except for it's obviously not Depot. So, in theory, I guess Die Depot, but no, or not no hablo German. No sprechen Deutsch, I think is how, no sprechen? I don't think that's correct. Anyway, I do not do the sprechening of the Deutsch. So, could not tell you. Anyway, here are some prices. The Y gantry and X gantry lengths here. This is total for left and right hand side as we have it designed right now. And then this obviously is some prices. I did not pull Amazon pricing because Amazon pricing tends to be more expensive on material like this. And because I'm doing this at home, I am not using the metal supplier prices that I could get at work, which is another avenue. So there's some potential that I could get it slightly cheaper buying it through work. Again, some potential, I'm not sure. But here are different ideas for materials. So this obviously is gantry material. So this is square tubing, aluminum square tubing right here in 1/20th and 1/16th wall thickness. And they're basically the same price for whatever reason from DOS Depot. Nuts is where I get my, that's not its full name. It's one of those things I'm not being paid to advertise. So this is where I get my extrusion from. I priced out really quick the 2020 or the 2040 extrusion. And as it turns out, it is actually cheaper than aluminum tubing. So one of these things where back to, it feels expensive sometimes, but frankly, extrusion is relatively cheap, especially when you compare here. Aluminum tubing, I did not check steel tubing. Steel tubing is a potential. I just imagined that it would be more expensive than aluminum tubing, which may be wrong on my behalf. I may be totally incorrect about that, but it would be worth checking. I just did not have the time. I was running up against the wall on the stream, so I had to go live. And then here's the 3/4 EMT conduit, which I have talked about and shown you guys on stream many times. We'll hop back to the camera right quick just for a reference. I've used this in various projects, not products. It is quite stiff, all right. For being as small and as cheap as it is really quite stiff. And I'd be comfortable with this on basically anything. I did recall actually one other thing I would say. If these do not ride over each other, we could still do setups like this where the x-axes are loose on top of the Y gantry. That is fine. We can do that, and then we can pick them up and move them over top of the other one to swap positions. So we can pick up one of these gantries and just swap it with the other one. We just have to, at that point, make sure I stand all the way up and clear the Z-axis, for example, the camera, so it does not bash when I'm swapping it, or B, completely release the Z-axis and put it on the desk really quick while I do the swap. So drop it down, let it sit on the desk, do the swap, and then reattach it to the X gantry. I totally forgot that is one other way that may be the way I end up doing it. But back to what we're talking about in Excel. So, as you can see, 3/4 EMT is obviously the cheapest by a long shot. It ends up being quite cheap at the end of the day. So this total length is actually the entirety of the Y gantry, as in the verticals and the horizontals. So for just over $20, we get that whole entire frame. And the only question is, frankly, whether or not the plastic holds up and doesn't break. It's actually more on the plastic, in my opinion, it seems to me, than the EMT. I also could have priced out. Actually, let me do that really quick. Das Depot. Let's see. Das Depot, 1 inch. 1 inch is $22.48. Calculator. 22.48 divided by 120 inches is 18.73. Repeating. Copy that. Put it into Excel. So, Das Depot 1 inch EMT conduit, and that was that many. So it's not even that much more expensive to go with the full 1 inch if we want to, if we're paranoid. Again, the 3/4 inch is quite strong in my experience. I could even try, I don't even know it's worth trying out the 1/2 inch. That may just be asking for too much. While we're talking about this, again, this is something I would have liked to check, but I just ran out of time. Let me double check PVC. Now, PVC flexes way too much, probably, especially at that size, but I'm just curious. I guess for comparison, 1 inch PVC. Yeah, 1 inch PVC is going to be way too flexible. It's going to deflect way too much, but I am curious. Calculator, there's the calculator. 5.23 divided by 24. So that's at 21. So that's more expensive than the metallic EMT. The M in EMT is metallic, so that was a bit of a redundant statement, but you understand what I'm saying. So PVC is more expensive. We will not be going with PVC. So those are options for the gantries. This is the Z-axis. This is my list of material for the Z-axis. Again, I wanted slotted stuff. So steel tube I really don't want to go with. It looks best, frankly. But unfortunately, steel is just way too heavy, comparatively speaking. And especially this steel tubing, the wall thickness is thicker than I would like it to be. But beyond that, obviously, as you can see, it's 81 cents per inch compared to all the rest of these. And these struts are, I think, decent alternatives to the full square tubing. I will go ahead and let me just get some, pull up the pictures just so we can see what we're working with here. Because unlike the EMT and the tubing and whatnot and the extrusion, those are all pretty easy to understand. But for these slotted angles and struts, you may not be familiar with that. So let me go ahead and pull this up. I'm just going into the preview editor to make sure that we are on the right page for Edge. And it's that one. Okay, push live. So here we go. So this is angle. We can use angle on the verticals. I would not want to use angle on the rest of the gantries just because it is more of a pain in the butt to use. It is slightly less of a pain in the butt using 3D printed brackets, but I'm still a bit sketchy on it. Again, it is technically, especially because, and I know I'm hopping around here on stream, but let's hop back to the camera, attempt to find the camera. Where'd my camera go? Camera? Oh, there's the camera. So, especially if we go with this situation where we're only doing rollers on top, you can do rollers on top of angle. You put the angle like this, and that gives you your two surfaces. So long as we have it loose, the angle actually 100% is an option. And back to having a 3D printed bracket, that makes our life a heck of a lot easier to do this, right? All we do is put a slot in the 3D printed bracket, and we're good. So for specifically the Y-axis, I think that's reasonable. for the z-axis it's not as reasonable, because for the z-axis I actually would want something that holds on 3 sides, because I really don't want this to fall off. So that is probably not going to work for the z-axis or for the x-axis, but it would work for the y-axis. And again, it's a bit of a pain in the butt normally on the verticals to attach the verticals to the horizontals, but with 3D printed brackets it is a valid option for the verticals as well. Back to the internets. So anyway, this is what we'd be getting possibly for the z-axis. Again, these slots in here just allow us to get in. Obviously on perforated angle they have different size slots as you go down, different sizes and shapes, which is not as ideal for us, but at the same time it's workable. I wouldn't complain about it. And then here are the struts I was talking about. They come in multiple sizes, but these are the 2 cheaper ones. This half size I don't know is sturdy enough. I mean, it probably is. Frankly, it's one of those things I may just be being a wimp. We maybe can get away with this. So one of those things, my only hesitation is that we kind of have to hug this with the plastic bracket, okay? So imagine a plastic bracket going around this, and then we also need wheels on the side. We'd want wheels on the side to smooth it out, right? Is what I should say. But the wheels have to be lined up exactly on the sides. Now granted, it's 3D printing, so it would be relatively accurate, but this gives us a lot more leeway going this way, is the only thing I'm saying. This one, stop it. This one, where is it? I'm trying to find it. Oh, 13/16. So 13/16 is about 3/4 of an inch. That's not terrible. That is relatively thick. For some reason, and if we go over here to Excel, for some reason, I thought that said 13/64. So this is wrong. I was thinking that it was about 1/4 inch, which is a big difference. There's a big difference between 1/4 inch and 3/4 of an inch. So actually, I'm more on board with that one now that I realize that's not 13/64. There we go. But alternatives. Oh, this steel tube. Let me hop back over there. I think I actually closed that one out. Yeah, it looks like I closed that one out. Let's see if it happens to be down here on the list. There it is. So that would be what the steel tube looks like. Again, way too heavy. Steel tube is way too heavy, in my opinion. But as you can see, it's definitely a lot nicer. It would definitely be a lot nicer looking, in my opinion, again, and this is my opinion, than this stuff, because it's symmetric. Yes, that is literally my only reasoning there, is that because it's symmetric, it would be nicer looking, but it is what it is. So those are prices again. So the X gantry lengths, I did not put this in here just because I probably should. I had it up here. I don't know why. I mean, I do know why I put it up here, because these could... Oh no, that's right, this is a Z. Duh. Wow, stupid. Okay. This is Z, that's why I don't have it down here. Yes, the x-axis can be those things. The z-axis is not those things. The z-axis is different. Derp. Wow. Okay. I finished my coffee about an hour ago. That's my excuse right now. Drink some water, pretend it's coffee. So, the z-axis I did not have an exact height on. I could assume the z-axis is about 2 foot. I could assume that's what we're doing. So if we do that at 24 inches here, then I could do cost per Z to get one of those prices, and that would be times that at 4 equals. So there you go. You can see how those prices really add up, especially here. Otherwise, frankly, I would not consider this much of a difference, and I would go with whichever one I really felt like. Now, again, we'll go ahead and, for the sake of argument, really quick get the price on one inch. Actually, I gotta figure out what the thickness is. Angle. While we're here, I'll check the price on angle. 1 inch angle iron. Let's see. Plain steel. Looking. I'm kind of curious whether or not they don't have aluminum angle. Yeah, they do have aluminum angle. Do they have 1 inch aluminum angle? Just to keep it light, you know? Because again, steel is heavy. Alright, so here's 1 by 1/8 thick. Let me add aluminum to the search bar. I wasn't expecting to be away this long, otherwise I would have swapped you onto the internet so you can watch me click buttons and be entertained by me clicking buttons, which is, you know, obviously why you watch people play video games, because you're watching people click buttons. That is a joke. Okay, it looks like I only have one option. Oh no, here's 1 inch by 1/16. Okay, so we have 1/16 and 1/8. And because the angle, and you can see my mouse right now, so because the angle is going to be like this on the x-axis and the y-axis in theory, I'm actually comfortable with 1/16 because it's going against the angle. So let's see. Okay, yeah, the 1/16 is definitely a good bit cheaper. So let us grab the calculator. Where's my calculator at? I closed it. Okay, calculator. Calculator. 14.47 divided by 36 equals 0.40. So let's toss that into Excel, and this is, no, stop. 1 by 1/16 aluminum angle, and that is that many's. So just a hair cheaper than tubing, so totally not worth it, frankly. And Das Depot, let's get the actual steel angle. Let me hit the back button. Steel. Let's see what steel angle looks like. 1 inch steel, there's 1/8. Do I have 1/16? Do I have 1/16? Checking. I am not seeing 1/16 in steel on the first page, which means that they probably don't have it, because I have 1 inch in the search bar. So let's back up to the 1/8. So at that point we're at 1/8, so it's going to be way more expensive. So 14.27 divided by 36. Wait, that is cheaper. That is crazy. Okay, whatever, it's cheaper. 0.27 divided by 36 is just a hair, but I'm actually surprised that you can get thicker steel iron. I guess it's the extrusion. I guess the angle, the aluminum angle is extruded, and therefore it's more expensive because of the die. I guess. So instead of being rolled, it's extruded, is my guess. 1 by 1/8 steel angle. There you go. About the same, but a hair less. When we round, it's the same. So that is that. Let's go ahead and sort this by, well, we can sort here. Largest, smallest. So there you see tube, angle. We're saving less than $10 here, right? On the Y. So I think I would still go with the square tubing just because it looks nicer. and we're not saving that much money. If we're saving more than $10, I'd probably go with the angle iron, but that is not the case. However, as previously noted, 20-foot extrusion, it is cheaper. Now, the only problem here is that, again, with the 20-foot extrusion, you can't really take the V wheels off of the extrusion. I could try just putting 2 V wheels on top and seeing what's happening. That's not how people normally do this thing, but the V wheels, in theory, let's hop over to DOS Fusion. Yes, everything is German now. I minimized that, so you now have the blue screen of death. Where is Fusion? There we go. So, back to... extrusion does have the channel, right? So, in theory, we could have the rollers on here and just assume they're not going to slip out of that channel. That's a bit of wishing, but at the same time, it may be a reasonable amount of trust in the system. It may not be unreasonable. The difference between this and the angle is that the angle has opposing wheels, slightly opposing. They're not completely opposing, obviously, but they have wheels going in opposite directions, which make them less likely, it seems to me, to slip off. Whereas this would have 2 wheels, let's say, in a row. So both wheels would be in the same exact plane, which means that it's a little sketchy, but again, it may be worth trying because the price is so much cheaper, unless, and here we will pop over to Excel and I will unminimize it so that you don't have the blue screen. Unless we want to try out the EMT. The EMT is significantly cheaper than the extrusion. It's about half the price. All right, a little less than half the price, but or a little more than half the price, I should say. It's less than 50% cheaper, but it might be worth investigating and seeing how well that works out, just because of the price savings, and it does what we want it to do. So because it does what we want it to do, and because of the price savings, it may... that is the one problem with round extrusion, though, which I should mention. Let's hop over to the camera. So, with square tubing, we're pushing on 2 sides, and this angle right here is stopping these guys from slipping, generally speaking. It may not be perfect, but it kind of works. And if we, for the x-axis, we actually could throw another one down here, and then 100%, this would not slip. 100%, we could have our doodad hanging off here, whatever it is, whatever object it is, hanging off this side, opposed by these 3 wheels, and it would stay oriented straight up and down, okay? That does not work with round extrusion. If we put a wheel anywhere, it doesn't matter where we're putting the wheel, and we hang something off the side, the center of mass, the center of gravity is going to just wrap around that tube because there's no solid angle for it to get caught on to oppose it, and it's just going to spin. So now all of a sudden, our camera, microphone, whatever it is going to be like this because center of gravity is going to want to be right there. So we can't use round extrusion on the x-axis. We can use it on the y-axis and the verticals. The y-axis, we can use it because we're spanning these two, which means that we actually have it can't slip because the x-axis will be fixed to a specific point on the y-axis, right on the rollers there. And because it's fixed on those points cannot wrap around the tube. They will be stuck and kept from wrapping around. So the EMT can work on these 3 pieces on each side, which is the most expensive part of the build. This is relatively less expensive, so it goes these parts, and then these parts, and then the verticals. That's the order of expensiveness for this build. We cannot, however, use this going across. So one way or another, this is going to have to be something else. However, this could be 2020 extrusion, the x-axis, I should say, sorry. The x-axis could be, I don't have it listed, but 2020 extrusion, which I already have. I don't have to buy that. So, because I bought it before. You know, I bought it at a previous date. So, and 2020 extrusion is going to be cheaper than 2040 extrusion. Obviously. So, that is that. So it may be worth doing the verticals and the Y gantry out of EMT, either 1 inch or 3/4, whichever, and then doing the X-axis out of something else, anything else, honestly. The last thing I guess I should say is, just for the record, the one way we fix the x-axis would be to have a double x-axis. So basically, remember I said because these two are opposing each other, we can use rounds up here. Well, we would just do the same thing for the x-axis. So our x-axis, ignore this front of the page. That is from our, what do you call it? The capacity design stream. Yeah. Capacitive, dang. My tongue. Capacitive touch sensors. There we go. That stream. That's what that's drawing is from. But for the x-axis, we could do tube and z-axis running through the middle of the two, and then attach to it on either side. And that was the single worst way to draw that, but that's okay. So here's the more isometric way to draw this. So here is tube and tube. So this is EMT and EMT. This is our z-axis right here, and this is going down towards the desk. And then we have plastic rollers. I mean, not plastic rollers, but you know, our 3D printed thing coming across here and attaching on both sides so that the z-axis going through the middle here cannot twist these out of orientation because they're opposing each other. So that would be the way we fixed it. That is still not a great way of drawing it, but here's a top-down view, which would be a better way of drawing it. We have our rollers here, we have our rollers here, we have a connection bridge in the middle, and the z-axis right there. There we go. So that is everything. Let's see. So do I want to do a design stream now that we've done an hour's worth of debating how exactly to put this together? Honestly, probably not. I'll probably just marinate on this and see where exactly I want to do it. I am leaning towards the conduit just because it is so much significantly cheaper. At least for, again, the Y and verticals, the verticals and the Y gantry. And then, as I have stated before, I need to convert my router sled over from 2020 to 2040 anyway. So I could pick up a box of 2040s and use those, part of those, for the router sled and take the 2020s off of my router sled. And then I'd have 2020s to use as the X gantry for to go with the EMT as previously stated, and then from there we can look at using one of these guys. Where's my mouse at? I can't find my mouse. There it is. Using one of these guys for the Z. Yep. Alright, that is everything. That is the stream. So, that is the 6th stream this weekend, which is on, I want to say it's on average. It's what I shoot for, so I'm happy that I hit it. I would have been better to have gotten a 7th stream in. I only streamed twice today instead of 3 times. What happened was I had to do a bit more work on the Dremel press than I expected. A bit more tweaking, I should say. It's not really work, it's just tweaking before I printed it. And then when I went to print it, my second SD card that I've used on the Prusa went. So I was without an SD card to actually get the files on there. I have been waiting for a long time to pick up a Raspberry Pi, hoping the price would go down. Spoiler alert, the prices on Raspberry Pis, even on 3s, has not gone down yet. So at this point, what I decided to do was I decided to Google alternatives. I was thinking about running a virtual machine since Raspberry Pi normally runs on a Linux, so I figured I could set up a virtual machine and do something with that. And then I found out that Octoprint is actually just a Python plugin. I mean, a Python module. So I found out I literally could just create a new Python environment, you create the Python environment because that's good practice. You don't necessarily need to do that, but create the environment just to isolate it, and then install Octoprint in Python and run it from there. Run the server from there. So that's what I did. I set up an Octoprint server on this very computer that you're staring at right now, and it is currently running in the background. It is not printing at the moment because I'm streaming, but it has printed two things so far. The top, what do you call it? Back to camera. Camera. This is the top part of top carriage. There we go. I've been calling it the top carriage. And then right before, a half an hour before stream started, this got done. As soon as I can get it off the print bed, let's go ahead and turn the exposure back now that I'm not staring at the auto. There we go. Now I'm not staring at the notepad. We don't need to read the notepad, so we can put the exposure back so it doesn't look like I'm living in the dark. So there we go. Those are two things I printed so far for the I actually do not want to print the bottom carriage until I have the whole entire handle assembled. I'm going to go ahead and assemble the handle first and make sure everything looks right. And then I think I'm going to print a test piece to make sure that the Dremel actually attaches to the bottom carriage correctly before I print the whole entire bottom carriage, because the bottom carriage is the largest component and takes the most amount of time. So I will do that first. But otherwise, now that I have Octoprint running on my computer, I don't have to worry about SD cards not working and dying on me, and I can just get back to printing. So that was that. As you can see, I already have the linear bearings installed in there. The rods I'll cut down at work tomorrow because it's easier than using my jigsaw jig. Jigsaw jig is nice. It's nice to have on the weekend, but I'm literally going to work tomorrow, so I don't need to use it because there's no rush. So I will cut the rods at work and get the rods installed and have the handle working prior to proceeding. So that's the update, my little update on the carriage. On the Dremel press, rather. That is the carriage, but on the Dremel press. And the whole entire point of that tangent, just to remind us, is that is the reason why I did not get my third stream in today, because I was busy sorting that stuff out. And now I don't need to go out and spend $120 on a single board computer. Yay. Although I was thinking about heading down to Micro Center. Again, biggest problem with Micro Center for me is that it's an hour away. So it's an hour worth of driving, and I was thinking about doing it actually to pick up I was hoping to pick up a Raspberry Pi. They don't have any because, again, Bitcoin. But if I had gone down, I was going to pick up a Raspberry Pi Pico, or not a Raspberry Pi Pico, but a Pi Pico, whatever it is. Actually, a Raspberry Pico. It might just be a Raspberry Pico. I totally forget. Anyway, I've seen some reviews on them. Figured I've been wanting to give it a shot, and if I was going to end up at Micro Center anyway, I figured I'd pick one up. Plus, I got one of those coupons which expired today for the free flash drive / SD card. So that's always a nice bonus. In other news, back to now that I'm running this server on my PC, it would be a good idea if you were listen to the discussion that I had, the talk session that I had the other day, yesterday morning. I did mention that I have a second PC that I've been wanting to do stuff with. I just cannot justify sinking the resources into it to get it running again because it has a faulty motherboard. However, now that I'm running a Pi server, and if I ever get my Ender 3 back up and running, I'd be running 2 Pi servers in theory on one computer. That is slightly more justification to getting this second PC fixed so that I could run the Pi servers off the second PC instead of my main PC. So, that is that. And let's see, anything else to say? Any more updates on the channel? I don't think so. Grimdark has, or not Grimdark, I keep on calling it Grimdark because I'm so used to Warhammer. But GrimQuest has been interesting. We will be doing one more session, maybe tomorrow. I might do it tomorrow. The fact of the matter is that I have not done any sessions for Light since yesterday. I should have done some this morning, but again, the printer problems got in my way. So that is a bit of an issue. I should get that done, but it's one of those things. Session 1 for that, or the first half of the next session, which is section 16, I believe, in Light can happen tomorrow after I get home from work. And then after that, I will stream. And again, that may just be GrimQuest to get our third session in and decide whether or not I feel like actually buying the game or stopping, because again, we're currently on the demo and I have a list of other games that I looked into and am considering playing. So that is, I believe, the full update on the channel. Anything I did not mention, I am not going to bother mentioning right now because there has been no progress since the last time I mentioned it. So there you go. One of those things. Feel free to watch other videos on the channel if you're interested in the other projects that are technically in progress but are a little bit stalled out right now, and I should be hopefully getting around to finishing in the near future. So anyway, if you have been watching, thank you, and as always, I hope you have a great and wonderful day, afternoon, or evening wherever